Thanks for tuning into the Health Econ podcast today. We're going to tackle Chapter 5, and the title of the chapter is The Labor Market for Physicians. All right, so far, we've shown that the Grossman model can be used to help us predict what quantity of health consumers would wish to produce if they wanted to maximize their utility. And prior to that, we decided that the demand for healthcare is downward sloping. So there's one side of the market that we just haven't looked at all, and that is the supply side. So the question we're going to try to answer today is, what about the supply of healthcare? The first thing to note is that the suppliers of healthcare are physicians. So if we're going to have any supply of healthcare, then we need to have physicians. So given that, what I'm going to do to start with is walk you through kind of the makings of a physician, or how do we get people to become suppliers of healthcare. Side note, if you're listening to this and you're actually considering going into medical school, please chime in on the comments, and I'm interested to know if we have any aspiring doctors. Hopefully this lecture gives you a little bit of inspiration. Okay, so to become a physician, then obviously the first thing that you need to do is you need to complete your undergraduate training. And undergrad takes 4 years to complete most of the time. And towards the end of undergrad, if you're going to apply to medical school, then you have to take a test called the MCAT. The MCAT is kind of like a GRE except for doctors. So it's the test you have to take when you're applying to medical school. One thing to just be aware of is very few people actually get accepted to medical school. So even if you get an outstanding MCAT score, that doesn't guarantee that you'll get into med school. So only about half of the people that apply to medical school actually get accepted. But let's suppose you apply to medical school and you get in. You would begin medical school at some point after undergrad, and medical school lasts for 4 years. If you go to a public university for medical school, the ballpark cost of med school is about $140,000. If you get accepted to a private university for medical school, then the ballpark cost of medical school is about $225,000. So it's incredibly expensive. In medical school, your time is kind of split into 2 periods. So in the first part of medical school, you take classes, kind of like you take classes in undergrad. So you sit in a lecture hall and you have a professor and they explain things to you like anatomy and pathology. And it's all very head-based knowledge. And that's definitely important. But the issue is that during that period of medical school, you really don't get any experience working with patients. And that's a little bit problematic because you need to pick a specialty within medicine. And depending on what kind of doctor you are, your day-to-day life as a doctor will be very different. So what they do to kind of rectify this is towards the end of medical school, med students do clinical rotations. So maybe you would do run rotation in emergency medicine, and you would just kind of observe and see what life is like as an ER doctor. And maybe you would do another rotation in surgery, and you would see what the life of a surgeon is like. And then maybe you do another rotation in a primary care clinic, and you would just kind of get the taste of that. After rotations, medical school students have to decide what residency program they're going to apply to. Okay, what is residency? Residency is when these young doctors get practice working on patients. So what that means is that residencies have to be specific to specialties. And one thing to keep in mind is that different universities offer different residency programs and different specialties. So for instance, not every university with a medical school offers a residency program in pediatrics, for example. So what you'll need to do towards the end of medical school is you'll need to figure out what specialty you want to go into, and then you'll have to think about what particular residency programs you want to apply to. So let's say that after rotations, I'm kind of on the fence between becoming a pediatrician and becoming a family medicine physician. So I look at the different universities that have residency programs in pediatrics and family medicine. Maybe I apply to 3 different schools' pediatrics residency programs, and I apply to some other schools' family medicine residency programs. Okay, the residency programs will get all the applications from the medical school students, and they'll look them over, and then they'll invite some of the medical school students to come interview for a slot in their residency program. So maybe I hear back from the pediatrics residency program at the University of Colorado. I fly out there, I see what it's like, I meet the physicians, they meet me, and then I do this for each residency program that extends me an interview. Okay, after this process, everybody goes home. What happens after this? After the interviews, all the residency programs will consider the people they invited to campus, and they will rank the candidates. So each residency program will say, John Smith was our favorite person, Sally Miller was our second favorite person, and they'll just do this throughout the candidates. And then similarly, all the medical school students who interviewed will go home, they'll think about the places where they interviewed, and they'll rank the places. Okay, at this point, all the residency programs and all the students submit their rankings, and then there's this big sort of machine that just kind of takes over. So everyone's rankings are compiled, and then there's this big algorithm that matches medical school students to residency programs. Okay, every year there's one day that's just huge in the world of medicine. It's called Match Day. Match Day is the day that the matches that the machine makes between medical school students and residency programs are revealed. So across the United States, every fourth-year medical school student finds out on exactly the same day, Match Day, what the machine decided for them, or in other words, what residency program they're going to go to. Residency programs nationwide in the U.S. and across all specialties begin on July 1st. So after you graduate from medical school and you find out where you're going to go do your residency, you move there pretty quickly, and then on July 1st, you begin working as a resident in the program that you've been matched to. Okay, one thing to keep in mind is that residency is when you first get to actually start working on patients. So it's kind of like this practice stage where there are people supervising you, but you're actually in like a real hospital or a real clinic treating real people who are sick. So as you can imagine, if you've never done this before, then the very first day that you start practicing on patients, you're probably going to make some mistakes. And this actually shows up in the data, and we have a name for this phenomenon. It's called the July effect. Basically what the July effect is if you plot patient mortality rates across the year or some other patient outcome, then there's this spike in mortality around the beginning of July. And it's because we have all these brand new baby doctors who are working on patients for the very first time, and inevitably errors happen. So if you ever need to have surgery and you can help it, try to schedule it for springtime and not July. Okay, the duration of residency depends on what specialty you're looking at. At minimum, so if you want to be just like a plain vanilla doctor and go into family medicine, then residency will last 3 years. It will last longer and up to 7 years if you go into a specialty that requires a little bit more skill. Okay, after residency, if you want to be a very specialized doctor, or if you want to be a doctor who works in an academic medical center as a professor, then after residency, you have to also complete a fellowship. Fellowships are optional, but it's kind of like this additional training, again, if you want to specialize in something very specific or if you want to teach. Okay, the duration of a fellowship varies depending on what type of fellowship you're doing. At minimum, a fellowship is going to be 1 year. A fellowship could last up to 5 years. At this point, what I want to reinforce is that it takes a lot of time to become a supplier of healthcare. And to help you kind of start adding up all these numbers to get an appreciation for this, on the screen right now, I've replicated a figure from your textbook just so you can get a visual for how long it takes to become a doctor. If you start at the beginning of this tree, which by the way starts after undergrad, so you already have 4 years under your belt of college. First of all, doctors have to go to 4 years of medical school. Then again, if you just want to be like a plain vanilla doctor and go into family medicine, then the residency program for family medicine is generally 3 years. If you want to be a surgeon, then you should count on spending like decades in school. So if you want to be a basic surgeon, then you're going to have to spend 5 years in a general surgery residency. If you want to be a specialized surgeon, so for example, say you want to be a cardiac surgeon, so you want to be a surgeon who specializes in heart surgeries, then you'll have to go through 5 years of general surgery residency, and then after that, you'll have to do an additional 5 years in a cardiac surgery fellowship. Okay, one other field on the screen is internal medicine. Internal medicine is what you study if you want to be a doctor who works in a hospital. So if you want to be a general hospitalist, you'll spend 3 years in an internal medicine residency program. If you want to specialize in heart conditions, so cardiology, or cancer, which is oncology, or geriatrics, then on top of the 3 years that you'll spend in an internal medicine residency program, you're going to have to do an extra 1 to 3 years of fellowship training to be like a specialized hospital physician. So the summarization is, it takes a lot of time, and it also takes a lot of money to become a doctor. But we need doctors if we want suppliers of healthcare. So the question I want you to think about is, given the high cost of becoming a doctor, when is the time and money investment worth it? To help you conceptualize this, let's just think about a person. And let's say this person is trying to decide career paths. So maybe you're in a similar situation right now. And this person, he's considering becoming a doctor, and he's also considering becoming a surfer. The way we're going to simplify this is we're going to have the person make their decision based on which career path will yield a higher return. So let's just start with the case of a doctor. If you're thinking about becoming a doctor, then the first big perk is that you'll have a high salary. The downside is that, well, you have to pay for medical school, which is super expensive. And then on top of that, in order to get the high salary, you'll have to wait like roughly 10 years to get it, because you'll be in training for such a long time becoming a doctor. And so the huge amount of money that you'll eventually start making is kind of way off into the future. Okay, on the other hand, things are a little bit more simple if you decide to become a surfer. To become a surfer doesn't really require going to school, so you can just start work immediately. So day number 1, you're getting a salary. But the downside is the salary you're getting is relatively low compared to the salary you would have gotten if you had become a doctor. To operationalize this, we're going to assume that the person is just going to choose the career path that maximizes their net present value. Okay, what is net present value? Net present value is the discounted sum of all future earnings from time period 0 onward, and there's going to be a discount factor, delta, that's between 0 and 1, and delta is a measure of how much less the individual values future income than present income. Okay, that's textbook definition, so let me kind of give you a very simple analogy. The idea of a net present value is, imagine you have this guy at the beginning of his path of life, and he's kind of looking down the path into the future at certain points along the path, and he sees that at different points along the path he's going to be making different amounts of money. So his net present value is kind of like how much he values the future streams of income that he's going to get throughout his life. Okay, importantly, if you have 2 different people looking at the exact same streams of income, they're probably going to value those exact same streams of income different amounts, because people differ in terms of their patience level to wait for money. So we're going to let delta be this thing that captures people's patience levels. It will permit people to have different net present values when they look forward into the future and just kind of anticipate identical streams of income in various time periods of their life. On the screen right now is the equation for net present value. And first of all, as you can see, it has delta in it. Delta is going to be bounded by 0 and 1. That means that one end of the spectrum, you're going to have people with deltas that equal 0. A person like that has absolutely no patience for money at all. Any money that they don't get today is money that is of no value to them. And then on the opposite end of the spectrum, you're going to have people with deltas that are equal to 1. So these people are extremely patient. So if on the last year of their life they're going to make $1 million, well, those $1 million are going to be just as valuable to them as if they had gotten them today. So in that sort of person's mind, $1 million is $1 million regardless of when they get it. Okay, in the equation, t is going to index the particular time period we're looking at, and we're going to look at time periods that start at t equals 0. Then in each time period, what we're kind of going to do is we're going to take the person's delta, we're going to raise it to the value of the time period we're looking at, and multiply it by the income the person would get in that time period, and that's going to give us a product. We're going to take that product for each time period and just add it up across the person's life, and so that will give us the person's net present value. So the disaggregated version of the summation will look like what is on the screen right now. One thing that is important not to get mixed up on, okay, in the equation there is an I parentheses t parentheses. That is a function. So that means that a person's income is a function of the time period you're looking at. Again, I want to emphasize you're not multiplying an income level times the time value. What that denotes is that income is a function of the time period that you're looking at. Okay, I'm going to go through the math with you just so that you can get an example of how all of this works. So let's go back to the example of this person we've been thinking about who's trying to decide between a career in medicine versus life at the beach. First of all, let's assume that this person we're thinking about has 3 time periods in their life. So again, we always start at time period t equals 0. So we have t equals 0, t equals 1, t equals 2. That's 3 time periods. And then let's also assume that this person has a delta of 0.2. Okay, first of all, note that 0.2 is closer to 0 than it is to 1. So this is kind of an impatient person. And that means that if he's going to be making lots of money at the end of his life, he doesn't really appreciate that a whole lot. Like, he likes money now. Okay, if this person becomes a doctor, then in the initial time period of his life, t equals 0, he would have an income of negative $140,000 simply because he has to pay for medical school. And the next time period, t equals 1, his income would be $100,000. And in the period after that, his income would be $100,000 again. To calculate this person's net present value, if he decides to become a doctor, we would first take his delta of 0.2 and raise it to that initial time period where t is 0 and multiply it by negative $140,000 because that's his income in time period t equals 0. To that, we would add his delta of 0.2 raised to the next time period, which is t equals 1, and multiply that by his income in that next time period, which is $100,000. And then finally to that, we would add his delta of 0.2 raised to the next time period, which is t equals 2, and multiply that by his income during time period t equals 2, which is $100,000. From here, you can just kind of plug and chug with the math. The first term is going to be equal to negative $140,000. For a moment, just pause and think about what that means. The person is kind of impatient, and on the very first day of his life, he'd have an income of negative $140,000 if he became a doctor, and he's going to feel all of those negative $140,000. Okay, the next term is going to be $20,000. Again, pause for a minute. So what is actually true when this guy looks down the path of his life is that he will see that in the second time period, he's going to be making a full $100,000. But he's kind of impatient and he doesn't like waiting. And so he's only going to value those $100,000 at a level of like $20,000. The last term is going to be equal to $4,000. Again, pause and think about this. In the last period of this guy's life, he's actually making a full $100,000. But when he looks down the path of his life, that last period, it's like super far away. So those $100,000 are just like so distant that the guy really doesn't care a whole lot about them. So that last $100,000 paycheck, right now, he really only values it at about $4,000. So you add up all the values, and this person's net present value, if he becomes a doctor, is going to be negative $116,000. Again, for the visualization, this means that when the guy looks down the path of his life and he sees, day number 1, I lose $140,000, I get $100,000 the next period, I get $100,000 the period after that. In total, he kind of values that whole stream of income across his life at what is equivalent to negative $116,000. All right, now let's see what would happen if this guy became a surfer. If he became a surfer, then every time period of his life, let's say he'll bring in an income of $20,000. So mathematically, you would take his delta, 0.2, and you would, first of all, raise it to the initial time period t equals 0, and his income during time period t equals 0 is $20,000. That gives you term number 1. He would add to that his delta raised to the next time period, which is 1. His income in time period t equals 1 is again $20,000. And then finally, the last period of his life, he still has a delta of 0.2. We raise it to 2, since we're considering time period t equals 2, and his income in t equals 2 is still $20,000. And now we plug and chug. So the first term ends up being $20,000. That means that in the initial time period, he makes $20,000. How much does he value that? He values that at $20,000. Okay, the next time period, he would again make $20,000, but this time he would only value it at $4,000 because it's further away. The time after that, he would still be making $20,000, but how much does he value it? He values it at only $800 because that's just like super far into the future. So overall, he looks down the path of his life and he thinks about what would happen if I became a surfer, and he sees a constant $20,000 salary in each period of his life, and because of his particular level of patience, or in this case, kind of impatience, he's going to value that whole stream of income at what is equivalent to about $24,800. So the question remains, which career path will this guy choose? If he's only choosing based on which career path yields the highest net present value, he'll choose to become a surfer. All right, so this is interesting when you think about this in the context of becoming a doctor and then thinking about what specialty you want to go into once you're in medical school. So if what is true about people is that they're impatient, and that if you make them wait a long time to get paid, then they're less likely to choose that career path, then let's just think about a person who's decided to become a doctor, but they're trying to choose their specialty. Well, if they choose to be a cardiac surgeon, they're going to have to wait like forever to get a paycheck. And so this would probably discourage some medical school students from wanting to become cardiac surgeons. And instead, we might expect medical school students to have a stronger preference for things like family medicine because the training is shorter. The problem is we need cardiac surgeons. So if people actually think in this way that's consistent with net present values, and if we want people to become specialists like cardiac surgeons, which takes a long time to do, then we need to make the payout at the end of all that training like super, super high, because specialists like cardiac surgeons are going to have to wait a super long time to get whatever payout we give them. Okay, now let's actually look at some empirical figures. On the screen right now, I have a figure that shows you roughly how much physicians in different specialties make. To start with, I'm just going to highlight the top earners. The top earner is orthopedic physicians. So these are people who specialize in bones. Orthopedic physicians make about $421,000 per year. After that is people who go into cardiology, so heart physicians. Again, these are specialists who have longer residencies. And what you'll kind of notice if you look towards the top of the figure is that the highest earners are physicians who are quite specialized and their training is quite long. Okay, what about just like plain vanilla doctors, so people going to family medicine who don't have to spend as much time in training? Family medicine is second from the bottom. They make $195,000, which is a lot, but relative to other doctors, they're some of the lowest earners. Okay, what I want you to recognize is that there's a correlation between salaries and how long it takes to complete training for particular medical fields. In other words, for specialists where they have to spend a lot of time in residency and in fellowships, what we see in the data is that those doctors make quite a bit of money, and for the medical fields where the physicians spend less time in training, those doctors don't make as much money as the specialists. Okay, let's just very briefly tie this back to economics. So economic theory would tell us if we want people to be incentivized to go into, first of all, medicine, because all doctors have to spend a considerable amount of time in school, and in particular, if we want some doctors to go into specialty fields where the training is super long and they'll have to forfeit income for quite a long time, then what we're going to have to do in the market is we're going to have to pay those we'll have to pay doctors, first of all, and then particularly specialists, more money, because to get their net present value up to a sufficient level so that it exceeds the net present value of an alternative career path or specialty, the payout in the latter periods of life just needs to be especially high. Okay, in closing, there are two things I want you to take away from the graph. Thing number one, all doctors get paid well, and this makes sense given that all doctors have to go to school for a long time. And on top of that, they also have to pay for medical school, which is expensive, and so early periods of their life, their incomes are going to be negative. Thing number two is the doctors whose training is even longer get paid even more. And for all the reasons that we talked about, this is exactly what we would expect to observe in the world. Okay, we made it to the end. If you have any questions about any of this, chime in on the comments, and then after the question period, we will resume for the exercise. The exercise I'm going to have you do today is basically to play around with the net present value equation so you can start to get a handle on the mechanics. And I have 2 questions for you. They'll hopefully help you think about net present values just from different angles. Question number 1, suppose you have a person named Andy. Andy is considering becoming a doctor. His discount factor is delta equals 0.8. He will live for 2 periods, t equals 0 and t equals 1. If Andy becomes a doctor, his income in t equals 0 will be negative $100,000, and his income in t equals 1 will be $400,000. What is Andy's net present value of becoming a doctor? So your answer to number 1 should just be a number. Okay, number 2, we have a person named Polly now. Polly is deciding between becoming a doctor or a travel agent. She will live for 2 periods. If she becomes a doctor, then for the initial period, she'll have to pay $100,000 for medical school, while she'll make $350,000 in salary the next period. If she becomes a travel agent, she'll make $50,000 in each period of her life. Assume Polly only cares about maximizing her net present value. What value of delta would Polly have to have for her to become a doctor? State your answer in terms of an inequality. So for example, your answer should be of the form, Polly would have to have delta greater than a particular number, or Polly would have to have delta less than, and then fill in the blank for the number. Once you have answered those 2 questions, you will be good to go for the day.